Hello, 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 hello. I am Learning Tech. I'm here to walk you through a topology that I have made, a multi-area OSPF topology. I really like OSPF. OSPF is a layer 3 protocol, routing protocol. OSPF makes a puzzle with its neighboring devices by using LSAs. LSAs goes to the area border router, and it builds up like a map or a puzzle, so you know what devices are in the area. Now, multi-area OSPF is nice because if your area is too big, let's say there's more routers, if it's too big, it will really slow down your network. So you can have another area, like area 20, and it breaks up your network, and your network can stay quick and efficient. This is more for bigger networks, not necessarily for small networks. If you have a small network or a small office, regular OSPF is just fine. Now, when you're doing OSPF, you always have to have your areas connected to area 0. Your area 0, the backbone area, is like the spine, the heart of OSPF. Alright, let's get into configurations here. I already configured the PCs. I'll show you what I did here. So I did the default gateway 192.168.10.1 is router 1 right here. Now a default gateway is anything that's not in this network, send it here. And router 1 will send it out and it will be on its way to the correct network. Now the IP address for my PC is 192.168.10.10. I can put that on there. .10. I did that for both here. .10. The subnet mask is 255.255.255.0. And that's the local area network that we're in right now. So PC2, basically the same thing. The default gateway is this router here, 192.168.40.1 right here. And then the IP address is 192.168.40.10. Subnet mask 255.255.255.0. Okay, let's start configuring the interfaces here. I'll go to router 1 first. No. Enable conf t. I am going to do the host name first. Configuring the hosts are very important. You always want to know what device that you're on. When you're doing like SSH, it's going to ask you to have the host name configured. So I always like configuring the host name first. I am also going to make a loopback interface on the routers. Now loopback interfaces I like because they're logical. So the loopback interface is directly on the device. So the only time you can't connect to the loopback interface is basically when the device is completely down, completely off. That's when you can't reach it. But the loopback interface is always up when the device is on. So interface, loopback interface here, IP address 255.255.255.255. So with the subnet mask, I'm saying with the 255.255.255.255, it has to match 1.1.1.1.1. Now OSPF is a wildcard mask. Wildcard masks are opposite from subnet masks. You see what I mean when I configure OSPF. Interface G00, IP address 192.168.10.1. Oh, forgot to put the rest of it. 255.255.255.0. Now I'm gonna do interface 01, IP address 10.0.12.1, 255.255.255.252. No shut. So I did no shut on this interface, but not the other interface. Now I'm going to show you how that looks. Do show IP interface brief. Now, just because I configured G00, it's still administratively down, and protocol is down. Now this one is up, but it's still protocol down. And the reason for that is R2 is shut. Now when you're configuring routers on the interfaces, you always have to do no shut. Switches are different. You don't have to do no shut on switches because they're already open. That's why port security is very important on switches. So I'm gonna go back to interface G00 and I'm going to do no shut. You see the notification here, the syslog number 5, and then if you go back to the IP interface brief, it will show you that it's up. So the switch, I didn't have to do shut or no shut, it's already up. And router 1 G00, when it's up, you put the status on up, the protocol will also be up when it's connected to the switch. You should also see up when you do no shut on the routers interfaces on both sides. Okay, no. Enable conf t IP. Wait, I want to do host name first. Host name R2 interface loopback IP address 2.2.2.2 255.255.255.255. Interface G00, no shut, IP address 10.0.12.2 255.255.255.252. Okay, now if I go back here, you see how it was down before on G01. You see the message here saying G01 change state to up. I go back and look at it, now it's up. Okay, that means it's now open, it's no longer shut. Now I'm going to interface G01. I'm going to do no shut first so I don't forget. IP address 10.0.23.1 255.255.255.255. Oh, just kidding, it's 252. My loopback interface already did, but my loopback interface is good, 255. Okay, I'm gonna go here, router 3, new, enable, T, interface, I'll do host name first, host name R3, IP interface, back, IP address 3.3.3.3, 255, 255, interface G00, no shut, IP address 10.0.23.2, 255, 255, 255, 252, interface G01, no shut, IP address 10.0.34.1, 255, 255, 255, 252. Okay, R4 here. I'm gonna move it over here so I can still see it. Answer is no. Enable P, host name first. R4, interface, loopback, free address, 255, 255, 255, 255. Interface, G00, no shut. IP address will be 10.0.34.2, 255, 255, 255.252. Interface G01, IP address 192.168.4D.1, 255, 255, 255.0. No shut, don't forget that. Okay, so all the interfaces should be configured. Now, if I try to ping PC2, it shouldn't work. Ping 192.168.40.10. It should come up as unreachable, and it does. Unreachable. Or if I try to ping R2, router 2, 10.0.12.2, that should also time out. It shouldn't reach there either. I should be able to ping router 1 though. I should be able to ping that. Ping 192.168.10.1. And I am. So, what happened here? Unreachable. And you see this right here, 192.168.10.1. That's the default gateway. That's right here. So the ping said, hey, I want to, PC1 says, hey, I want to get all the way over here. The default gateway, router 1, says, I have no idea how to get there. That was the same problem of getting to R2. Pinging R2, R1 had no idea how to get there. So even though we configured the interfaces, they still need to know the next hop. And you can do that with static routing, but we're going to do it with OSPF. So let's get started. I'm going to start on R1 first for OSPF. Okay, let's go exit. Let's go router OSPF 1. Yeah, let's do process 1. And then let's do a router ID. I like router IDs. Okay. And then I'm also going to do the loopback. Network 1.1.1.1. Now this is the wildcard mask. So just like how 255 for a subnet mask has to match everything in that network, that number in that network. 0000 means this has to match. All four numbers have to match. It's wildcard mask is just the opposite of a subnet mask with numbers. This will be area 10. And then I'm going to do network 192.168.10.0. And this will be 255. No, just kidding. Wildcard mask. Aha. I just got done telling you. If you're not careful, you can make that mistake. Network 10.0.12.0 000.3 area 10. So dot 3 is the same as 252, so it's like a /30. But wildcard masks, they're opposite of the subnet mask numbering. Okay, and then you also want to do passive interfaces if you're connected to like a PC, only because passive interfaces are important because it stops you from sending unnecessary information throughout the network. So when you have a passive interface, it won't send all the LSAs, etc. that OSPF uses to communicate and update the network, so it keeps your network efficient. So passive interface for this PC will be G00, and then I want to also do it on the loopback. And there we go. They're looking good. Now let's go to R2. Exit. Router. Oh, just kidding. Fat fingered that. Router. OSPF 1. Router 2.2.2.2. Network 2.2.2.2. 0.0.0.0. Area 0. And then we're going network 10.0.12.0 0.0.0.3 area 10. So it's connecting to area 10. But like I said before, everything needs to connect to area 0. That's the backbone. That's the important one there. So let's go ahead and do that here. 10.23.0.0.0.3 area 0. Oh, let's do that again. There we go. I'm missing a number. 0. There we go. There we go. Okay. Now all the areas have to connect to area 0. They have to. Now let's do a passive interface, and it will be the loopback. Okay. Now we're on router 3. Will be exit. Let's do a router ID first. Router OSPF 1 router ID 3.3.3.3. Okay, network 3.3.3.3. Area 0. There we go. We're looking good. Okay, 10.0.23.0 0.0.3 area 0 network 10.0.34.0 0.0.0.3 area 20. So we got to make sure it connects to area 20. The passive will be the loopback interface. Now let's go to router 4. We're finishing up here. Hit exit. And then let's do router OSPF 1 router ID 4.4.4.4 network 4.4.4.4 area 20 network. You can also do this too. You can do it like this 0.255.255.255 area 20, and that means the 0 means that the first octet will have to stay the same. So the 10 right here of the network will stay the same, and the 255, all these can be different numbers. So that's the way you can do it. You can also do it with you can also do it directly on the interface. Let's do it directly on the interface. 192.168.4D.1 0.0.0.0 area 20. Okay, you can make sure your interfaces are right. By doing the do show IP OSPF neighbor command, and it will show you who's your neighbor. So remember, neighbor ID 3.3.3.3 full adjacency, so that's good. They fully did a handshake. Right here, I can do the same thing here. Do show IP OSPF neighbor. Look at that. So 3 is neighbors with 2 and with 4. Also, you want to check your OSPF, make sure it's right. You do show IP route. So you're connected. C means connected. That's your connected route. It will tell you it is directly connected, and it will tell you what interface. Your local, that's what L means. L means local. It will also tell you directly connected, the interface, and this is the OSPF. This is the puzzle that it made through its neighbors. The OSPF, it will tell you the loopback interface right now. O stands for OSPF. IA right here, OSPF inner area. It will tell you the network. So that's really good. And you want to make sure you check on all your routers for it. Do show IP route, because they all should be the same. They shouldn't be missing anything. Do show IP route. Alright. Do show IP route. Nice. So now this ping should work when I'm trying to ping PC2. 192.168.40.10. So the first time I did that, it was unreachable because router 1 didn't have any next hop, but now it works just fine. So the ping PC1 was saying, hey, I want to make it all the way over here. So it sent the ping to R1. R1 went to the next hop. That was the next hop to get to the next network. Same thing here. To get to the next network, went to the next hop. Next network, went to the next hop. And that's it. I just needed the information for the next hop. Now let's also see if PC2 can also ping PC1. That's all important. Make sure it goes both ways. Ping 192.168.10.10. And yep, it's reachable. And that right there, ladies and gentlemen, is multi-area OSPF. Thank you for watching.